So in today's lesson, we are talking now more about graphs of cosecant and secant functions. These two graphs are very similar to sine and cosine. So if you can graph those two, then secant and cosecant will be fairly easy to follow. So the first thing I want to show you is how they're actually related. Okay, so here's our sine graph. Okay, I put it in as dash. So again, we can see those highs and lows and where it's crossing your x-axis. Okay, and actually, let's change our settings for our. Let's go negative pi, 2 pi to 2 pi. So that way we can see. Okay, so we can see it in radians. Okay, so how is secant related to this? Well, remember secant is the reciprocal of sine. So that means, notice that there are little U shapes kind of at the highs and lows points of our graph. And then notice that your graph, it looks like it's kind of approaching some asymptotes. And these asymptotes are actually very, very important. So notice that at 0, right, x is equal to 0, we have an asymptote. At x is equal to pi, we also have another asymptote, right? At x is equal to negative pi, it looks like we have another little asymptote. So we're going to have some graphs, we're going to have some asymptotes where our graphs are not going to cross. Okay, so secant and cosecant are related to our original sine and cosine graphs. So here is our examples of cosine. So here's cosine's graph. So again, at 0 radians, it starts at 1 and then goes down, follows that up and down motion. So then again, secant, we're going to see those U shapes again on our graph. Okay. And again, notice this time the asymptotes are not at pi's or at 2 pi's, but now notice it's at pi over 2, because again, the if cosine is 0 at those values, pi over 2, negative pi over 2, that means the reciprocal doesn't exist. Okay, and so again, we have these asymptotes. So instead of saying pi, we now can say pi over 2, and now I have an asymptote at pi over 2. And again, instead of negative pi, I can say negative pi over 2, and we can see another little asymptote. Okay, so how can I graph these? Okay, so let's get into the nitty-gritty of actually graphing them. So let's start with cosecant graphs. So cosecant, again, is the reciprocal to sine, which means that the period is still 2 pi. Okay, and again, the graph of y is equal to cosecant of x approaches some vertical lines starting at 0 and occurs every pi. And the reason, again, why this is so important is that sine, right, if we think about it, when sine is somewhere between 0 and 1, I'm going to take away asymptotes, so between 0 and 1, technically 1 can be included, then our cosecant is actually going to be greater than 1, because again, we'll flip all those fractions. And again, if sine is in between 0 and negative 1, then our cosecant, again, is now going to be smaller than negative 1. So that's why we're going to see those U shapes. Okay, so how do we graph? Okay, so in order to graph our cosecants, we're going to do 3 little steps. So the first one is you're going to graph the function as if it said sine. You might even want to make a light little sketch of it if you think it's needed, right? So when I say sketch, maybe you want to say, you want to do, right, your it in a dashed form for your sine, and then again you can put those vertical asymptotes in, and then those and then our U shapes. And then this is important at the zeros, aka the first, third, and fifth numbers. That's where we're going to draw our vertical asymptotes. Okay, because again, the first number will be at 0 pi, the second number is always at pi, and then the third number or the fifth number is at your 2 pi. So again, that's where sine gives you 0, which means its reciprocal is undefined. And then finally, at the minimum and maximum points, you're going to make U shapes. So at minimum, it's going to go down, and then at maximum, it will go up. Okay, so max, you're happy. Minimum, you're kind of sad. You're going down. Okay, so that's essentially all that we need to do. So let's take a look at our parent function, and then we'll take a look at some other examples where we can see a b value, we can see that c value, we can also see that d value. Because again, just like we could say our sine value, we can still have all of these a, B, C, and D attached to our equation. So here is example number 1. F of x is equal to the cosecant O of x over 1 period. Okay, so I can still find my information. I can still find my amplitude. Our graph technically doesn't really have an amplitude because it is going forever and ever up and forever and ever down. But again, it's important to find it because again, we want to reiterate that it's kind of like sine and cosine. So there is no amplitude. And again, our period is still going to be found as 2 pi divided by the absolute value of b. So there is no b value. So our thing is still 2 pi. Again, I can still set up my intervals 0 to 2 pi. There's nothing to add, subtract, multiply, or divide. So I know I'm done. And then I can set up my my actual intervals to find my 3 terms. So add 0 plus 2 pi, divide that by 2, right? So I get a pi. This will be pi over 2, and this one's 3 pi over 2. Remember, whenever you don't have to add or subtract or multiply or divide, these will always be your x values. So how do you find your y values? Okay, so our y values, again, remember that this follows the sine graph. So sine is going to start at 0, 0, 1, 0, -1, and 0. And then again, I don't have any a value to multiply by. I don't have a d value to add. So that means I'm done. So I'm done with y's. So it's important to notice that these guys right here, I'll highlight them. So this guy right here, this guy right here, and then this guy. First, third, and fifth. These are your vertical asymptotes. So you have 3. Your graph starts with 1 and ends with 1. So how do I put this information on here? So just like before, pi over 2, spread it out pi. Remember, everything's evenly spaced. And then 2 pi, I'm going as high as 1, as low as -1. And then I'm going to make my points. And I'll make my points in a different color. So let's make them in blue. So 0, 0, and then pi over 2, 1, pi, 0, -1, and then pi. So if I wanted to, right, I could make a light sketch. If I wanted to make a little light sketch of this, notice again, it's dashed, so I can easily erase it. Okay, so again, notice that it kind of looks like sine. So then the next thing I'm going to do is I'm going to draw my vertical asymptotes. Well, my vertical asymptote for the first one will be my y-axis, so it's hard to see, but my second one and my third one are a little bit easier to see. Okay, so then at the maximum points, I have a max point up here. I'm going to make it look like a U shape, so it's going to go up. And then at my midpoint, I'm going to make it go down. So the graph of cosecant is in black. So really everything that I drew in blue, I don't necessarily have to keep. So if I wanted to erase this lovely dashed line of a graph, I can. Okay, and again, I'm left with my vertical asymptotes and just my U shapes. Okay, So let's see what happens if we start adding some amplitudes in, maybe some b values in. So let's try a second one. So again, still over 1 period. Again, I like it. We know it's going to be just like the sine. So it'd be looking like whatever the sine of 2x is b. Amplitude, so the a value, absolute value, it's still 2. My period is 2 pi divided by 2, which just gives me pi. So again, it's been horizontally shrunk. Okay. Again, I can set this up using my inequality. And then I'm going to divide by 2. So divide everything by 2. Again, you don't need to necessarily set up your inequality unless you definitely have a b value. Then you really need to set it up. Everything else will always start at 0 and at whatever your period is. So 0, blank, 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 and then pi. So my first value will be 0 plus pi divided by 2, which will just be pi over 2. That one's pretty easy and straightforward. Number 2, 0 plus pi over 2 divided by 2. So pi over 2 times a half gives me pi over 4. I always like to make them become the same denominator so I can easily find my values. So 0 pi over 4, pi over 4. This must be 2 pi over 4, which means that my third and final number should be 3 pi over 4 because this guy is 4 pi over 4. So here are my x values. To find my y values, again, it starts at 0, 1, 0, -1, and 0. What am I going to do? I'm going to multiply by my amplitude, multiply it by my a value, not just my amplitude, in case your a value is negative. So 2 times 0 will give you 0, and then 2, 0, -2, and then 0. Here are your y values. So again, I'm going to plot these points. So pi over 4, pi over 2, 3 pi over 4, and pi, I'm going as high as 2 and as low as -2. So again, the amplitude really just tells you kind of, it's pulling your graph further and further away from the x-axis, so to speak. Again, I'm going to put the sine graph in blue. So I'll put all my points, so 0, 0, 2, 0, -2, and back to 0. Again, if I wanted to connect those points, I can. I don't necessarily have to. And then my asymptotes are always at my first, third, fifth number. It just happens to be 0. Boom, 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 boom. And again, I'm going to create U-shapes at my maximum points, opening upward, again, going towards my asymptote, and then U-shapes going down with my minimum points. All right, so now we've seen it with a value, we've seen it with a b value. Let's go ahead and add all 4 things in for cosecant, and let's also change our period. Let's make it over 2 periods. All right, so example number 3, y is equal to -2 cosecant of 2 pi x plus pi, add 1, graph it over 2 periods. So again, this is the reciprocal of sine. So again, my amplitude is 2, so it just means it's being pulled apart a little bit more. My period this time, I'm going to take my 2 pi and I'm going to divide it by my b value, which also happens to be 2 pi. And so my period is actually 1. Again, there is a shift. There is a horizontal shift. So I'm going to go ahead and set up my intervals. And again, I'm always setting it up, starting at 0, ending at 2 pi. I don't change my period yet. Period will change eventually. Remember, this is just to help us figure out what our starting and stopping points are. So I get 2 pi x and just pi, and then divide everything by, 2 pi, not just 2. 2 pi, and I'm going to get a negative 1/2 all the way to a 1/2. And again, the distance between a 1/2 and a negative 1/2 happens to be 1. All right, let's find our actual intervals. So blank, 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 1/2. So these are my x values. If I add my first term and my last term together, they cancel out, giving me 0. So this actually ends up being 0. The number in between 0 and a negative 1/2 is a negative 1/4, which means that this is also a 1/4. In order to find my y values, so again, this is going to start at 0 and end at 0. I'm going to first multiply it by my a value, which happens to be negative 2. And again, I could add it, I could also add in the 1, but I sometimes like to take it one step at a time. And then I'm going to add 1. And so my final values are going to be 1, negative 1, 1, 3, and then 1. So these are my y values. Now, you're going to notice something interesting. You're going to notice that none of my values are going to become a 0 anymore. But just remember, the first term, this number doesn't exist, which means if it's undefined, I can't add a 1 to it. So my first number, my third number, and my fifth number are still going to be vertical asymptotes. Because again, these are all sign answers, which means that they could have had a reciprocal. These don't have reciprocals that exist. All right, so again, we want to be a little careful about that. Okay, so what we are going to do is we are going to first plot our original numbers. So this will give you negative 1/2. That'll be negative 1/4, which means that this is going to go to a positive 1/2. Nice. I'm going to make my numbers at, oh, I forgot to put my x-axis and y-axis. So it's going up all the way to 3, technically down to negative 1. Okay, so negative 1/2 should be at 1. Then I'm down at negative 1, back up at 1, 3, and then 1. Okay. But again, my first number and my third number, it's always hard to see when it's on the axes, and my fifth number are all going to be asymptotes. So I'm not going to cross my vertical asymptotes. It's going to look like that. So again, notice that the amplitudes, again, just pulled these apart a little bit more. So I can continue. I can continue my my second period. So I can make this. So again, it's going by a fourth. So technically, this is 2/4. So this will be 3/4, 4/4, 5/4, and I need and then 6/4. That's where I will end. So again, it's every other one that is going to be an asymptote. Okay, and then my highs and my lows. So again, it follows the same pattern. So 1, this will be negative 1, 1, this will become a 3, and then right back down to 1 at that point right there. And then we will connect the points together. Boom, boom, and then up like that. So again, this happens to be from here to here my second period. Again, not that we have to label our second period. All right, so now that we've seen a couple examples of cosecant, let's figure out what secant's graph kind of looks like. So secant graphs, again, secant is the reciprocal to cosine. So again, when we see that 0, cosine is in between, 0 and 1, then our secant of x is going to be greater than or equal to the number 1. And again, when cosine is between negative 1 and 0, then our graph again for secant will now be less than negative 1. Secant still follows the same thing. Our period is still 2 pi. The graph of secant approaches a vertical line starting at pi over 2, because again, cosine at pi over 2 gives you 0, And again, it occurs every pi. So pi over 2 and 3 pi over 2. So you're going to actually see less asymptotes. But they follow the same idea of how to graph them. So we're going to graph the function as if it was cosine. Again, make a light sketch if needed. And this time at the zeros, second and fourth numbers, we're going to draw our vertical asymptotes. Because again, oops, sorry about that. The second, I don't know what happened with my graphs. There we go. Because at our second number, it becomes pi over 2, and again, it doesn't exist. And then 3 pi over 2 doesn't exist. Again, at our max points and our min points, we're going to make U shapes. Now, we have to remember that we actually kind of have a little bit more U shapes for our asymptotes. So sometimes the U shapes might not be complete. So I'm going to write not complete. And I'll show you kind of what that means with our first graph. Okay, so let's do the parent function without any A's, B's, C's, and D's, because again, we can have all of those values in our equation. So here's our first graph. So f of x is equal to the secant of x. So again, this graph's just like the cosine of x. So again, I can find my amplitude. There's no a value, so it's just 1. Period is still 2 pi divided by the absolute value of b. So this is still just 2 pi. I can again set up my intervals by using this lovely equation. Again, we don't have to do that unless we really have a b value where things are moving left and right. And if it really truly starts at 0 and ends at 2 pi, these values are never going to change. Oh, hold on one second. Not sure what's happening with my. Sorry about that. Fixed it. Okay. So what was I saying? Starting it. So as long as there's no b value change and there's no c value, you really don't need to set these up. These are all gonna always be the same. So this will always be 0, pi over 2 pi, and 3 pi over 2. Okay, so again, these are your x values, and our y values will still stay at 1, 0, -1, 0, and 1. So let's go ahead and plot these. So pi over 2, pi, 3 pi over 2, and 2 pi. Oh, realized over here when my battery died, forgot to write that down. Again, I'm going as high as 1, as low as -1. So I'm going to start at 1, go to 0, -1, 0, 1. Again, if I want to make a light sketch, I can, and it would look something like that. My asymptotes are going to be at my zeros, so that would be at my second and fourth number. Okay, so we definitely have some minimum and maximum points. Now notice that my minimum point is in between two asymptotes. So I can draw a complete U for my minimum point. But notice that my maximum points right here doesn't have another asymptote to follow. So I can only follow my asymptote. So I actually only need to draw part of my U shape. So this is why it's kind of incomplete. So I'm going towards my asymptote. I have no other asymptote to the left, so I'm all done. When I come over to this side, again, I notice I only have an asymptote to the left-hand side, so I only need to draw part of my graph. So these two pieces come together, they form a full U shape, but when we separate them out, they're only parts of it. Okay, so let's see what our graph looks like again now that we add in a B value and an A value. So let's try this one first. Example 2. Again, we'll graph it over one period. So my amplitude is going to be a half. So this time our graph is just going to be a little bit closer together. My period is going to be found as 2 pi divided by a half. So that's the same thing as saying pi over 2 times 2 over 1. So this one's going to be stretched out a bit. Again, there's no horizontal shifting. So if you did not want to set it up this way, you didn't have to. But if you wanted to, you can. So I'm going to go ahead and I'm going to multiply everything by the number 2. And so that's going to give me 0, x, and 4 pi. Set up my intervals. And so 0 plus 4 is 4. Divide that by 2. I get 2 pi as my answer. 0 plus 2, again, add that together. I get 2 pi. Divide that by 2. I'm going to get pi. And then a 3 pi over here. Evenly spaced. My y value. So again, secant goes with cosine. So again, start at 1, 0, -1, 0, and 1. So I do have an a value this time. So I'm going to go ahead and I'm going to multiply by a -0.5. So don't forget the negative. So this will give you -0.5, 0, +0.5, 0, -0.5. So again, this is still my y value on my y-axis. So let's graph these out. So pi, 2 pi, 3 pi, 4 pi. Let's go as 1/2, and -0.5 is down there. Again, plot our first numbers in blue. So -0.5, 0, +0.5, 0, -0.5. We are then going to do our asymptotes at the second and fourth number. So this time I see a maximum point, because again, our graph's been reflected over the x-axis. So this will be your complete U shape. Let's go towards up. These 2 points are your minimum points. So again, go towards my asymptote, and I'm going down. Again, graphing only over 1 period's worth. Okay. So let's add in a horizontal and a vertical shift. And let's graph this over 2 periods. So final example number 3. So secant of 2x minus pi minus 3. Oops. Okay, so again, I don't have an amplitude, so nothing's really being stretched out. My period is 2 pi divided by 2, so my period is just pi, so that's my length, remember. I do have a horizontal change, so I do want to set this up using my inequality notation. So I'm going to add pi first to both sides, and I will get pi, a 2x, and a 3 pi. And then I'm going to divide everything by 2. So pi over 2 to x to 3 pi over 2. Again, pi over 2 to 3 pi over 2. Again, that gives you a period length of pi. So let's find our 5 intervals. We already know what we start with. We already know what we end with. So my first one, this one's a little bit harder. So pi plus 3 pi, so this will give you 4 pi over 2. Multiply that by a half. So this will give you a 2 pi over 2. And then again, I'll do the second one. So this will be a 3 pi over 2, again, times a half. So this will become 3 pi over 4. I'm going to change everything to a denominator of 4. So 2 pi over 4, this will become 4 pi over 4. So that must mean that this is 5 pi over 4. And then this would be 6 pi over 4. So that worked out perfectly. All right, so let's go ahead and plot our points. So pi over, actually, I'm going to skip a beat. I'm going to make this just pi over 4. And I'll make this the 2 pi over 4. And then 3 pi over 4. 4 pi over 4. 5 pi over 4. And then 6 pi over 4. Again, you could write them out simplified. That's perfectly fine. Okay, so we found our x values. Let's find our y values this time. So again, it starts at 1. It ends at 1. I don't have an a value to multiply by, but I do have a d value, so I am going to subtract by 3. So 1 minus 3 will give me -2, -3, -4, -3, -2. Remember that my fourth and second terms are automatically asymptotes because, again, I can't subtract a number to an undefined value, right? So those guys are 3 pi over 4 and 5 pi over 4. This time I'm going to do my asymptotes in a highlighter. That's what I feel like doing. Okay, I'm going as low as -4. So 1, 2, 3, 4. And that's it, as high as -2. So I have a little bit of empty space. Didn't think about that as I was graphing. Let's change colors, make it green this time. So 2 pi over 4, that will be at -2. This will be at -3. Again, that one doesn't really matter because it's an asymptote. -4, back to -3, and -2. So again, my minimum points between my two asymptotes can make a graph go down, and this graph is going to go up, and this side is going to go up. Now I can continue my my graph. I can make, again, I want to make it become an asymptote. So it looks like I skip every other number. So 3/4, which means that 1/4 pi should also be an asymptote. And then it'll be 0. So then this would be, so let's follow the pattern. So if we started at -2, starting at -2, then I'm going to go back down to -3. So it makes sense that it becomes an asymptote. And then my next one's going to become -4. I'm over here at -pi over 4, so that will probably be another asymptote because that will be back at -3. And then this will become -2 pi over 4. And that number, we're right back to -2. So the great thing about this, the great thing about our, I don't know why it keeps moving. The great thing about our second period, and I'll draw our second period in a different color. Let's do purple. Okay, so now notice that this has another asymptote to follow. And then this had two asymptotes. So that's nice. And then this doesn't have a second asymptote, so it's just going to go up. So no matter what, I'm always going to end and start a period looking like it's part of a U shape. And again, between -pi over -2 pi over 4 to 2 pi over 4, again, that distance is still going to be pi. So we've graphed secant, we've graphed cosecant, a few examples. If you have any questions or concerns, please reach out to me.